Okay, so we're starting our next unit, Unit 3, and this one's all about polynomials. So this first lesson is all about just breaking down the basics of polynomials. I know you've dealt with them some, but we're just going to dive a little bit deeper in than what you probably hit in Algebra 1. So first, let's talk about standard form of a polynomial. Your standard form is whenever the powers are in descending order. For example, you have like 2x squared minus 3x plus 4. And I'll say y equals. So that would be a polynomial with the powers in descending order. And if you forgot what a power is, that's your exponents. So the degree of the polynomial is your largest power on the variable. So for this, the one that I gave you, the degree of that polynomial would be to the second degree. Okay. So now they give you some fancy names, and these will be handy to know. And a lot of the homework questions ask you to identify or classify the polynomials by the degrees and number of terms. We've already talked about this earlier. Number of terms, a monomial, mono means one. Binomial, bi means 2, tri is 3, and a polynomial is 4 or more. So if there's 4 or more terms, that's a polynomial. And usually they'll say a 5-term polynomial or a 7-term polynomial. Okay, now this might be where it's a little bit different. Okay, classifying it by its degree. So if there's no degree or it's just a number, like 3, that would be a constant. Actually, let's do it this way. So that would be a constant polynomial. There's just a number, there's no variables. A linear would be, there's an x to the first power. The quadratic, we just finished a unit about this, would be x squared. So that would be an example of a quadratic. A cubic polynomial will be to the third power. So let's say x to the third. That would be an example of a cubic. A quartic, quartic. And I sometimes have to think about these two. A quadratic, you think quad means 4, which it does. But on this one, quartic means a fourth degree polynomial. So let's do like 3x to the 4th. That would be a quartic polynomial. And then quintic. Quin means 5. So let's say x to the 5th. That would be a quintic polynomial. Okay, easy enough. It just might take a little bit of studying to remember those words. No big deal. Okay, so now let's talk about characteristics of a graph. So they're going to have continuous smooth domains. So that means it's going to be steady. There's going to be smooth turns. There's not going to be any asymptotes where it does something crazy. The number of terms, this isn't always the truth, but I should say the number of possible, so possible terms is n minus 1. So your degree of the polynomial minus 1. And then we're also going to talk about end behaviors. So this little cheat sheet, and this is something I would definitely recommend screenshotting. This really helps. So if you have a polynomial function with a leading term, blah, 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 if your exponent, so this is the exponent, is even, so n is your exponent again. This might just help you see it so you don't have to think, what's n? So if your exponent is even and the a term, the coefficient, coefficient in front of, and let's say coefficient in leading term. Remember, this is for standard form. So if it's not in standard form, put it in standard form. So if your leading coefficient is positive and the exponent is even, it's going to be up and up. If it's positive and the exponent is odd, then it's going to start, let's draw a picture. So up and up would like this. Down and up would look like this. I'm going to erase this and draw this a little bit different because there could be some other stuff going on. So it could be like this. We'll do like a break in between because you don't know what's happening in between. If it's an even exponent and the coefficient is negative, it starts down, look at me go again, and it continues to end down. And if the leading coefficient is negative and the exponent is odd, it starts up and finishes down. So this is just something I would definitely have handy. It will help you a lot on the rest of these notes and for your homework. So here's one of those examples. So the polynomial has an even coefficient and the exponent is positive. So that would start up and end up. So this one, as you can see, it does have some turns and stuff like that and roots. So it looks like this one might have 4 roots. Okay, so that's not always the case, but it can be. Oh, here's a good old parabola. So if it has a negative out front and your exponent is even, it's going to go down and down. So this has one turning point. Okay. And then here's an x cubed function. So this would be since it's a positive coefficient and the exponent is odd, it would start down and go up. And this one, it has, looks like 2 turning points. I need to use a different color. Turns here and turns here. And since it's a negative, odd exponent, it would start up and finish down. Okay, so again, I know this is a lot thrown at you pretty quick, just something to definitely reference back to. And whenever you're doing the homework and you're referencing back, it will start clicking. Okay, so describe the shape of each function and then determine the end behavior and number of turning points. So remember, the number of turning points, or I should say possible turning points, is n minus 1, and n is your largest power. Okay, so this one, let's do the turning points first. So that would have, it's a 4, so that would have 4 minus 1 would be 3 turns, or potentially 3 turns. Doesn't always, but it has up to 3 turns. Okay, and then it will, since it's an odd number and it is an even exponent, it's a positive number and an even exponent. Positive number, even exponent is up and up. So this would be the end, would be up and up. Next one, the turns would have 2 turns, or up to 2 turns. Then the end, so since it is a positive number out front and an odd exponent, it would start down and then finish up. Okay. This one would have 2 turns as well. And then the end would, since it's negative and then it's still to the 3rd power, it's going to be the opposite of what it was over here on letter B. So this would be up, it would start up, and then it would go down, finish down. All right, and the last one of these would be, this would have up to 7 turns. And then it would end, would be up and up. So this is the end. Like on this one, it could very well start up here and then do a bunch of squiggles and then end up. It could look something like that. The higher the degree of the polynomial, the more funky, crazy turns that you can have, but don't worry about that at the moment. We're just worrying about the end behavior. Okay, so now what is the degree of the polynomial functions that generate the given data? So how you do this, the steps to doing this, is you find the difference in y values multiple times until, wait, I don't have to spell until. There we go. You get a, or let's say constant, no, we'll say consistent number. Then the second step is the number of times is the degree of your polynomial. Now you're probably like, what? So when you're doing this, you might want to go slow. So on this one, you're going to go this way, and this would be like -1 minus -7. You're minusing it. So that would be plus positive, so that would be 6. Okay, here, -7, again, minus -3 plus positive would become 10. Oops, no, I did that wrong. -4. Okay, from here to here, this would be -3 minus 5 would give you -8. Five minus 11, what would that be? -6. 11 minus 9 would be 2. And then 9 minus -7 plus positive, that becomes 16. Okay, so it's not consistent yet, so we have to keep going. So what would be 6 minus -4 plus positive, that would become 10. -4 plus positive 8. So let me, remember that's a -4, don't let that blue positive sign. So -4 plus 8 would be 4. -8 plus 6 would be -2. And then we would have -6 minus 2 would be -8. 2 minus 16 would be -14. Okay, here we go. We're not consistent yet, so we need to keep going. Let me switch colors. So 10 minus 4 would give me 6. 4 minus -2 would give me 6. -2 minus -8, so that becomes plus positive. That would be 6. Hey, this is looking good. -8 minus -14 would be 6. So good, we got a consistent number, which was 6 in this case. So this would be a third degree polynomial, which let's use the proper name, and that would be a cubic polynomial. Okay. Let's do one more like that. So we're gonna go, okay, so 23, these are gonna be bigger numbers. So 23 plus 16 would be 39. -16 plus 15 would be -1. -15 plus 10 would be -5. -10 plus 13 would be 3. -13 plus 12 would be -1. And then -12 minus 29. So that would be -41, I believe. Okay, let's keep going. So that would be 40. -1 plus 5 would be 4. Negative 5 minus 3 would be negative 8. 3 plus 1 would be 4. Negative 1 plus 41 would be 40. Okay, still not consistent. Let's keep going. So 40 minus 4 would be 36. 4 plus 8 would be 12. Negative 8 minus 4 would be negative 12. And then 4 minus 40 would be negative 36. We're getting closer. Well, maybe, I don't know. We're just getting less numbers. Okay, so what is the difference between 36 and 12? That'd be 24. What is 12 plus 12 plus 12 would be 24. Negative 12 plus 36 would be 24. Hey, we got it. So this would be a fourth degree polynomial, and remember that would be a quartic polynomial. And that is how you do that. All right, well, that is all I have for polynomials. Thanks for watching.